Hello everyone, welcome to the channel. In this video I'm just going to go over a backup emergency light. The circuit is pretty much identical to the board that I have in my other video that is capable of earth transmission. This one is also capable of earth transmission, but as this is just as a backup light, sort of like in case you have power outage or something, I've left that off. If you did want to connect that, you would be connecting earth to the base, and you would be connecting a light source to possibly the negative on your battery. You're at the emitter here, so negative on your battery, and in series and plugged straight into the ground. That's not what this video is for, so if you want to check that out, that's in one of my other videos. So I took the circuit apart and placed on it this red heat shrink just to make it a bit clearer on the wiring in relation to the schematic. And I've used one of these wire connectors just so that you can literally copy it off of there. If you start at your connection number 1, terminal number 1, and connect your transistor up accordingly, so that would go there, being the base being here and the emitter here, this one as it shows in the diagram there, and that would plug in just there, as you can see I've done there. Okay, so that's being run by a 12 volt 9 amp hour sealed lead acid battery, and this would run better off of a car battery that you could recharge during the day by a solar panel or something like that. And you could run this long distances if you wanted to. I'm not really sure of the actual distances, however, according to Tessa's notes, it should be a long way if you run it either by a single wire transmission, so again using that base connection here, plugging that into the ground, and then you could run your other wire off of negative of your battery, and that runs as far as you want, single wire, to your light bulb, and then out of your light bulb straight into the ground. So if you want to understand that long transmission, check that out in my other video. So in this one we're going to be running, to start off with, this light, which is sort of like a porch light. Probably a little bit much for this type of circuit, so it's probably the maximum 15 watts is this current draw when run on normal electricity. A normal electric circuit, 240 volt. I think the ratings are there. That's just an Audi bulb, cheap, but does the job. So there are lots of different bulbs, so this one here is the other bulb that will demonstrate, and it's a 9 watt bulb. So we'll plug that one in as well, and this will run on this circuit. It will empty that battery way too fast. So if you had like a car battery that you had no worries about supplying power to the next day, or a much larger battery bank, you can use this circuit. You will need to place a bigger heat sink and better connections for this circuit, because that heat sink, transistor will get way too hot if you go running something of this nature. This is like a 70 watt ceramic pet heater. Yeah, the type of thing you put above chicken or put next to chickens, baby chickens or something. Okay, so that's basically there to remind me to say in another video I hope to show you someone who is living in a cold environment. Ironically, I'm in air conditioning at the moment because it's so hot where I am, but brain's an amazingly weird thing, and so I thought of this as a heating unit, an efficient heating unit that I'll show in another video. So back to this one. I think probably the best bet is we connect this up. Sometimes when you go to start this, it won't actually start, and you know, in a lot of circuits similar to this, you'll see a resistor in line with the positive, or a variable resistor, which helps that start of that oscillation process. But if it doesn't start, just give it a second and then tap it back on there. Having a switch makes it a bit better because it's that faster change of contact. So alright, so if we just tap that on there, it's come on first time. The difference will be because of the light that you try to start it with, you know, that you're trying to run off it, so sometimes it might not start straight away. So you know, that puts out a decent amount of light, and if you shining that at your roof, you know, from a much bigger battery bank than that thing, you know, and in saying that, that will last you about 2 hours with this bigger light. If we take that one out, I will come back. I'll take this light bulb out, and then I'll come back and show you this smaller light bulb here. Okay, so back in a second. Okay, so that light there is the 74 milliamp at 240 volts. That would be, so I think this is the 9 watts, I think it said. Yeah, 9 watts. Okay, so again, that's an Aldi light. They're both that same brand, lightweight brand. Okay, so that's also a bright light. The other thing about this is once you've got your light running, if you have an earth wire, so an actual wire that's plugged into the ground by a metal rod, or an artificial earth, which is just a large mass, so a large piece of metal, a large roll of copper wire, as in this instance, and if we connect that to, put that under there so that we can see what's being done. If we connect that earth wire to other places on the circuit, we can actually see if there's any differences. And in this case, so I'm currently connecting that to the positive, and there's very little change or visual change. You might get it on a meter, but so there's no obvious change. Put it on the negative now, same, no obvious change. A collector, you might see a tiny bit, but nothing obvious. However, if I connect it to the high voltage line, so on the schematic, it's being connected here. Alright, so if we connect it there, you'll see if we watch the light, and I'll do it rapidly so that we can see an obvious change there. So everyone can debate why that happens. I believe it's because of the extra mass and the electrons in that mass, but anyway, someone will tell me I'm wrong, because again, I'm not educated in this, well, in conventional electronics. So there's the light. If we now remove that one, and we place there instead this smaller coil which just has a standard LED. It's 4 turns, probably what looks like 1 mil, or maybe bigger, maybe 2 mil wire. That doesn't matter too much. So in this instance it doesn't matter too much. So we've got 4 turns there connected to a single LED, and we can see that the circuit's still running. So if we just place that on top there, that lights up that LED very, very brightly. Probably a little too much actually. It's possibly, you know, too high voltage, too many turns. You could probably get away with less turns for a single LED like that. But it does demonstrate that wireless function. If I put that LED up near the circuit, we can watch the effect. So that's pretty straightforward. You can take the light off in that manner, but from what I've seen, you know, obviously up until a certain wattage requirement of these bulbs, there's not much benefit. The circuit seems to draw the same amount from the battery, and so if you just have that charged up the next day, you've got that reliable lighting source. Okay, I mean, if you don't have a spare 100 meters of wire, you could use something like this, which is a homemade capacitor, which is just 2 sheets of aluminium foil laminated with a piece of plastic between the 2 sheets, and the same deal will occur if we put that light bulb back. Okay, so that's screwed back in, and if we connect that to that high voltage line, we can see that also has that same effect. So whether that's acting as a capacitor, you know, anyone can make one of those with a couple of laminate sheets, a single sheet between the 2 pieces of aluminium, and you've got yourself a capacitor. If you can't get a wire to earth to ground, or if you don't have you know, 100 meters of wire. It doesn't have to be 100 meters, it just has to be a large mass, a collection of electrons that the circuit can oscillate through, in my opinion. Please like and subscribe. Check out my next video, which will be for those people who are experiencing the cold and want a reliable heat source for when it does get cold instead of a lighting source. So you could use the same circuit for both. This next circuit that I'll show you, which is again just another Tesla circuit. So yeah, go into your local hobby shop, get yourself some of these transistors, 2N3055, and that's all you need. So if it blows up because you're experimenting on what new light to operate on it, and it blows it up, grab a couple. That way you can get it running again straight away just by changing that one component. Everything else, usually 9 times out of 10, is okay in the circuit. It'll be this one thing. If you find a different transistor that you think works better than this one that I'm using, leave it in the comments so that other people can benefit from. On a 3D printer spool, and I've just hot glued the light fixture in there. No tricks. So yeah, if we turn it on so that those who are trying to work out whether it's relevant, whether they can be bothered continuing, can see. So just as a backup light source, the actual light there is unmodified. That's a that's the box there for that light. So it's a 240 volt light, 220, 240, 50 to 60 hertz, 74 milliamps. I mean, these lights generally aren't that expensive to run anyway, but yeah, the main concept here is to have that light easily made with minimal drain on the battery. If you had to run an inverter just so that you could have a light, that would, the inverter itself would take power from your system. So this is just a small 12 volt lead acid battery, one component. And that's the other important thing. If you had a bag full of these, that's all you have to ask for if you went into your local electronics store. A 2N3055 transistor. I've drawn the pins here for those of you who don't know and are new to electronics, and that's mostly the reason for this circuit, is for those that are new to this sort of thing, who want the advantages of a backup system but don't know what you're doing. I'm self-trained, so everything that I show you here is from a basis of not knowing what I was doing at all. Trial and error, whilst being careful, can give you some decent results. So we're just going to try and make this easy. You can see here on the schematic that I've highlighted in red the positive line, and you can see here that it comes in. If I use a screwdriver to point, my finger won't get in the way. So you can see here this line coming in to one side of the transformer. If we just turn that off, and flip it on its side just quickly, and you can see, so we've got one side of the transformer here as it shows on the schematic. So it comes in from the positive line, down that side, through the coil, which is 9 turns by filer. Okay, so that basically means it's double stranded wire, like two insulated wires side by side. And it's speaker cable that I'm using, but you can use any two wires. Excuse me. So these two wires laid on the core from one side to the other, giving us 9 turns. With the two wires, 9 turns for each wire. So that then comes across to this side, and that's this wire here. Okay, right, and it basically comes down to here and they're joined in together, and this is how they become bifilar. So that's these two wires here joined in together here at this terminal. Then it comes out through this wire, which then travels back through the coil again. So the impulse goes through the coil once, returns and goes through again very, very fast, and comes out this line and onto the collector. So it really is just a case of wiring that up the correct way. So this is the emitter, this pin here, and that's just going into the connector, and the emitter, for those of you who don't know, goes to the negative. So we come out of that side of the connector. These little bumps, as I said, I'm not electric, I'm not an electric engineer, so I don't know. I wasn't schooled on how to draw things. This is the way, I think I've seen that somewhere before, and I've stuck with it. So where you see that bump, that's that line there, red line, jumping over the black line. Okay, so not actually connecting, not touching, just that's to signify that it goes over, passes over. In the same way here, so you've got your emitter coming out. This is this black line here, and that goes to the negative side of the battery, and then again that negative side is one side of your high voltage lines. So here we go again, out of the emitter across to the negative of the battery, out of that same terminal, and then through to our high voltage light. So one side of the high voltage comes from the negative terminal. The other side of the high voltage light supply is the low side voltage wise on the coil, as far as I understand it, and I could be wrong. Again, I'm not trained, so I'm guessing a lot of my work is exactly that, guesswork, alongside of my own education, where I read enough to give me the concepts for the ideas that I have. And this has probably been done before, and that's not the point of showing this. The point of showing this is just if somebody who does not know what they're doing wants to build something like this, this is an easy way for you to do that. Alright, so if we connect that back up again, sometimes when you connect this, it may not start first go, and there are many reasons for that. I mean, it possibly should have a resistor in line with one side of that positive feed, but I tried to make this one as simple as possible, so there's nothing that can really go wrong other than the load itself, the light receiving way too much power and overheating, and the transistor cooking itself. So sometimes you need to, I find, if you tap this connection, and I find if it gets energized, so say it comes on and you've made the mistake of removing your hand accidentally, removing connection, you might need to wait just a couple of seconds. Like I said, you could probably put a variable resistor in line, but I wanted it so that it just, like I said, had one part to fail. Okay, so what we'll do is we'll get that going. If I struggle to do it. Okay, there we go. Okay, so we got the light going. So we can demonstrate quickly this. So this is 4 turns of copper wire, and that shows, you know, that lights that up nice and bright. It's LED. It doesn't matter which way. So if we unscrew this main light here, okay, we just leave that sitting there. Now that it's not electrically connected, but we can see that this 4 turns here. If I could try and get that in the same frame, would be helpful. Okay, so obviously that's transmitting through induction. I did mean to have one of my radiant energy collectors here, but I forgot to obviously get that organized. So we can see that that's just pretty much basic wireless induction. There's not much point to having you know, these smaller light sources connected to this system. The system seems to draw that same power consumption rate irrespective of you know, what light you place on it. And obviously if you go to incandescence, that sort of stuff, we're going to see a massive increase in input current. But as far as you know, just you should keep it, say, around the 10 watt or under as far as your load goes. And this is not a modified light. This is just your conventional light bulb. Sometimes when screwing these back in while the circuit's operational, it'll go out like it's just done there. And that's because frequency and oscillation changes. So just to get that going again, we will need to disconnect and reconnect. So we can see that I just touched it there and it came back on and then went off because I moved my hand away. So we just touch it a couple more times, so strike at it, and the light comes back on. This one's operating again. I mean, you can do what you want with this. You can make your other coils. You can make coils to the resonant frequency of this coil. It doesn't have to be on a 3D printer spool. The dimensions of that, you know, it could be a piece of plastic pipe, it could be whatever you've got, an empty pill bottle, or you know, whatever you can get a hold of. We will reconnect that. Alright, there we go. So it will run that, you know, for a couple of hours anyway. I've run it for. You know, certainly get you out of trouble if you have a power outage, or you know, even if you have an off-grid system and you would like to have your lighting for a lower cost. I mean, you could set this system out with your solar system and then run this power through the ground to your house or to your shed or whatever you want. You know, a tiny solar panel, you know, through a regulator charging this, and this one component, you know, that you go and buy 20 of or order them online, and you've got that backup light sitting in the cupboard waiting for the moment where it can get you out of some trouble for the night. Okay, so I mean, same again with this light. Probably won't be able to see as clearly, but if we were to connect that roll of wire, we could see a change in intensity. The faster I do it, the easier it is to see. Alright, so that's pretty much it. If you've got questions, if you don't know what you're doing, don't be afraid to ask, because that's that's the only way we're going to learn how to achieve these things without the amazing education that they lie to us about. Okay, thanks again for watching. Please like and subscribe and share this if you can. In my next video I will do I'll show a circuit, another circuit I've had going for quite a long time, another Tesla circuit, where we can use this as a heater. That's the strange thing about the human mind. I'm sitting here in plus 30 degrees and then thinking, I'm sure somewhere else in the world someone's cold. This 70 watt heater can be run. So collect a few of, buy a few of these transistors, because you will find, dependent on the load, these transistors can get really hot. They can burn out. Sometimes you can place a load on them that's too much. So for example, this 70 watt heater, that's actually a heater for like chickens or something. It's an animal ceramic heater. It runs on 240 volts. I think it's about a 70 watt, and so that whilst that will run on this circuit, it will cook that transistor, so you would need to supply that transistor with a bit more protection than the basic heatsink that I'm using. Okay, so in the interest of keeping it cost efficient, just using the roll of aluminium foil straight out of the box, nothing done to it, it's not even used, it's a new one, and jumper lead on the end, just on one end, and we connect that again into this high voltage line, and so we'll focus on the light, and so even that will give you that increase in intensity. As I said before, I believe it's because of the increase in mass and the extra available electrons to move, because their energy's not created or destroyed, but now it has a larger mass to move around. So yeah, if you're worried about how much it's all going to cost you, not as much as you would think. This chip be $1 a piece if you're getting it expensive. Some places, if you look around, you can get them cheaper if you can't find one. If you don't have a local store to supply them, you can get them online in various different places. So just in case anyone is wondering, running 240 volt lights, is a circuit dangerous? Well, when applied to other circuits, it can be dangerous, but in this instance, set up this way, You know, it really has no harmful effects that I've noticed. So, I mean, for example, I've connected jumper lead onto the high voltage line, where I placed this roll of aluminium foil, just to show you the increase in intensity and light. If I touch that roll of foil, it changes the fluctuation, but there's no harmful effect, and I'm touching the high voltage coil there in essence. So same with the other side of the high voltage line is 12 volt battery, so again, that doesn't do anything. You might get a little tickle off of the collector. You know, in saying that, like, you know, touch it, I can't feel anything. But under the right circumstances, please still be careful, because if this was to find a better way to ground itself through you, the parameters all change, so it can electrocute you, and it can do some nasty things to you. So always keep that safety aspect in mind. But yeah, you can feel a little bit more comfortable about working with the circuit, knowing you can touch the high voltage components of the circuit, and I can't actually tell. I can see a fluctuation in light just, but I can't actually feel or detect anything. But yeah, thanks for watching. Have fun.